Hi, today we will talk about the Redshift render settings. Knowing the features of the renderer allows you not only to achieve the best picture, but also to reduce the rendering time, which is especially important if you do not have a powerful computer. Click on this button and switch the renderer to Redshift. Go to Redshift Advanced, GI, and set both engines to brute force. Next, we will analyze this point in more detail. Now, Redshift Render View. Let's start by getting to know the Render View window. This button starts rendering with buckets, which means that the image will be as close to the final one as possible. Rendering in buckets is a rather lengthy process, so you won't be able to quickly evaluate the result of the work. But you will get good image quality. This mode is useful in the later stages of working on the scene or when you want to evaluate the final appearance of some detail of the scene. This button also starts rendering, but in the IPR mode, or progressive rendering. This mode, in contrast to buckets, tries to render the entire image as a whole and at the same time. It produces an image faster, but it is also noisier. It is needed to quickly evaluate the scene, but it is not suitable for the final render. In this mode, it is good to work in the early stages of the development of a scene, when you are just starting to set the light, evaluate the distribution of materials, or finalize the composition. This is the button for refreshing the render window. It's like hitting F5 in your browser. This button allows you to limit the rendering area to the selected rectangle. This menu item allows you to select a camera, the view from which will be on the render. This button allows you to lock the selected camera and always render from it. This is convenient when you need to get out of the camera and fix something, but at the same time you want to see the result of the fixes in the render in real time. This button switches the render mode to bucket rendering. We have already mentioned this mode in the lesson about lighting. It allows you to switch between beauty mode, between clay mode, and sampling. This button saves the current picture in snapshots. This is convenient for evaluating certain changes. I will do a few more renders so that you can clearly see how to work with snapshots. It allows you to view the gallery of snapshots and compare them. Select Set A, and you can compare your snapshots in different modes. You can pull this point, the slider, as well as this point, and the point here. Each of them controls a separate mode in which it will be convenient for you to evaluate snapshots. This button copies the current image visible in the render view to your clipboard, allowing for easy pasting elsewhere. This is the same as this Copy Frame Buffer option. Here you can see the zoom value. And here are different zoom modes. This gear icon are settings. There are many useful things here. We will cover them a little later. Now that we are roughly familiar with the render window, let's move on to the basic settings for the render itself. This is a very handy menu that allows you to quickly set up the most important stages of the render. We can immediately set the quality of the final render with one click by selecting it in the bucket quality item. Low will produce a noisy but fast result, and very high will most likely be an overkill as it will render for a very long time, while there will be no visible differences from, for example, the medium settings. This item is controlled by the threshold scale. Here you can set a custom value. Usually the medium settings will be enough for you. The next item is denoising. Denoise is an option that allows you to get rid of noise at low sampling and keep the render speed high. In the settings, we can select the type of denoise engine. OptiX is very fast and can be used during interactive rendering, but it's not as efficient as the others. Altus Single and Altus Dual are slow and do not work in interactive rendering, but give a clean result in the final render. Let's take a look at them in the render window. This button allows you to toggle the display of the denoise filter on and off. See how the noise level changes. I usually don't use denoise as render time is not crucial for me and I can tweak the sampling to avoid noise. But if you have a heavy scene that takes a long time to render, you can enable and configure denoise. The motion blur option is also very important for us. This effect allows you to blur objects in a scene in motion. This is necessary to create, firstly, a more interesting picture, and secondly, more familiar to the human eye. The brain expects and uses motion blur as part of its motion detection logic. Animations without this can look unnatural. We need to enable motion blur. There is a steps parameter here. More steps will result in a smoother blur and more accurate motion path, but also use more memory, which will result in longer render times. We also have a deformation blur option. This is a motion blur for geometry deformations, especially when you have an animated rig with a skin. Tracks and blurs the movement of the vertices. Global illumination is a very important item. It is enabled by default, and as you remember, in the advanced settings at the beginning of the lesson, we chose its type, brute force. Next, we will talk about it in more detail. Combined depth. The combined depth and the corresponding depth parameters described below determine how many times a ray of the corresponding type can bounce or travel through an object until it stops. The higher the depth value, the more realistic the rendering result is due to the render time. Global illumination depth, reflection depth, refraction depth. Transparency depth is a separate parameter that controls the transmission of the beam for transparency, or opacity. The combined depth parameter specifies the maximum limit for combined global illumination, reflections, and refractions. Hardware ray tracing. If enabled, any available hardware-accelerated ray tracing will be used if you are rendering with compatible graphics cards such as NVIDIA RTX series GPUs. Now let's move on to advanced settings. Here we will only touch on the parameters that are most necessary for us. Let's start with sampling. This is essentially the most important setting as it describes how many rays will be sent to render the image. So what is sampling? To explain this, let's take a look at how light ray works. Here we have a source of light and a surface. A light source emits a ray that has a certain intensity and wavelength, which is responsible for the color of the light. Some of this ray is absorbed by the surface, and some is reflected in different directions. In this case, the intensity, direction, and wavelength after reflection can change. Sometimes it even happens that the ray hits the inside of the object, refracts several times, and goes out in another place, as for example in translucent objects. After that, our eye or the camera matrix notice this ray and form a picture from it. Rendering algorithms try to recreate this process, but rendering the entire environment is time-consuming and resource-intensive. After all, light sources shoot rays in all directions, and there are many rays that can fly away from the camera and never get into the lens. To solve this problem, we will work according to the reverse algorithm. Now the camera itself emits rays that literally feel everything until they meet a light source. When a ray hits a surface, it records the color of the surface to the pixel grid. And then it refracts and looks for a light source. And the faster the beam reaches the light source, the more illuminated this pixel will be. And if it does not find it, it will mean that this pixel is in the dark. This way we can gradually fill each pixel of the image with information about its color and light level. One such ray is called a sample, and the more such samples we release from the camera for each pixel of the picture, the more accurate information about each pixel of our scene will be, and the less noisy the picture will be. Then we only need to use smart algorithms to optimize the number of samples, for example, sending them more to the illuminated areas and less to the shadow ones, where nothing is visible anyway. Well, to achieve the best quality with minimal render times. This is the essence of sampling. Progressive render is default in the interactive rendering in the render window, which is fast but quite noisy. I recommend switching this option to bucket rendering only if you are rendering a caustic scene. And for the final render, we have chosen a bucket render, slow but giving a good result. Buckets are squares in which the picture is rendered. Always select only this for the final render. Progressive rendering, rendered in stages or passes, and the whole picture becomes cleaner with each new stage of rendering. You can see the whole picture at once, but it will be quite noisy and will gradually improve. It is convenient to use progressive rendering for the shader and light setup process. Progressive rendering is controlled solely by the progressive passes setting. The default is 1024 passes. This number needs to be reduced, since such a large number of passes greatly slows down on the rendering. Usually 24 passes are enough for me. Some options are not available in this mode. Unified sampling settings, point-based subsurface scattering, photon mapping including caustics, irradiance cache, irradiance point cloud. Unified sampling is bucket settings. Here we have automatic sampling selected. This option allows you to get a reasonably good result without having to tweak the samples. The main parameter that needs to be adjusted at this point is the threshold. The threshold determines how sensitive the noise detection mode is. The lower the value, the less noise, and vice versa. Also, lower values increase render time, and it is important for you to find a balance. The default 0.01 value should work well for a variety of scenes. If you are using motion blur or depth of field, use at least 8 to 16 minimum samples, and max is from 256. It is desirable that the number of rays be divisible by 4. Show samples mode, which is very useful for us. This mode renders the number of rays for each pixel. Those parts of the picture that are indicated in white use the maximum number of rays. These are the noisiest areas, since it is in these zones that, trying to remove the noise, Redshift uses the maximum rays. This way you can see exactly where you are missing sampling. Let's see how the ray adjustment affects the picture. I will increase the minimum and maximum samples to 16 and 512 respectively. There are significantly fewer white areas. Use this mode to fine-tune your samples. If the white areas are in shadows, then increase the sampling on GI. If in reflections, then increase the samples in the material in reflection. In my case, I also need to increase the samples on SSS. Next, GI or global illumination. This parameter adjusts the number of rays bouncing. The more there are, the less noisy the picture will be. If this parameter is not enabled, we will not get a physically correct image, since the ray will bounce once, and the light will simply not propagate. We have this option enabled by default. I like to set both GIs to brute force. There is only one setting, rays, and it is easy to adjust. This value should also be divisible by 4. You can increase it to reduce the amount of noise. This value may need a very large number. I usually start with 512. Brute force, unlike Irradiance Cache, works with interactive rendering and also does a good job with a scene with lots of small details. Irradiance Cache is used for interior rendering. The next one is a very useful group of effects, Post-FX. After you've rendered the image, you can add post-processing. LUT is a color conversion. There are many such files, and each of them is a kind of color filter. In the LUT location, you can choose the path to the LUT files. LUT file shows which LUT is selected. You can play with your image this way and style it. Let's also take a look at the color control group of parameters. There are curves here that allow you to edit exposure, contrast, as well as red, green, and blue channels. Photographic exposure is a group of parameters intended for those familiar with camera control and includes ISO, aperture, and shutter speed, as well as various parameters for controlling colors like saturation. Pay attention to the white point parameter, which controls the color that will be removed from the picture. Vignetting darkens the edges of the picture, simulating the properties of a real lens. There is also a saturation parameter that allows you to adjust the saturation of the color. The next effect you will love is bloom. It creates a glowing halo around the highlights. Bloom threshold allows you to set a threshold value for the bloom parameter to become visible. The lower it is, the greater the likelihood of a glow appearing. Bloom softness controls how soft the light blooms appear. Higher values result in larger, more soft light blooms, while lower values result in smaller, tighter light blooms. Bloom tint is the setting for the color of the glow. Bloom intensity is the strength of the glow. Flare creates a colored flare effect on light areas. Here we have the same parameters as in Bloom. There is also a halo parameter, which makes it possible to create a glow around the highlights. Flare Tint lets you tint those colored highlights. And the next group of parameters allows you to create a streak effect, which looks like a lens flare from which rays are diverging. Streak tail controls the length of the beams. We can adjust the angle of these rays using the streak angle parameter. The streak softness scale determines how soft the rays will be. Streak number determines how many rays are generated from each highlight. Streak intensity controls how strong the beam effect will be. There is also another post-FX that stands out a bit, namely bokeh. For it, you need to specify a focal point, and everything else that is further than this point will be blurred. To do this, we will create a null, name it focus, and place it at the desired point. There is a focus field in camera settings. Put this null in it. Next, let's create a redshift camera tag on the camera. Now in the redshift camera tag, under the bokeh tab, select the override and enabled options. And in focus settings, select the derive from camera focus distance mode and set up the COC radius. We can also add very beautiful chromatic aberrations. That is, color separation in the bokeh image item. We need to enable bokeh image in this tab. Set normalization mode to unit intensity and select the file. A pack with such files can be found in the lesson's description. Here you can see the chromatic aberration, which is most noticeable on the fish. They give a film effect. And now I want to talk about the output settings. Let's talk about color space. I must say that there are a lot of color spaces, and our displays operate in a narrow gamut color space, sRGB. The narrow gamut means that they can display fewer colors than the human eye can distinguish, that is, only 36%. For example, the familiar image formats, JPG, PNG, are also in sRGB. But unlike monitors, 3D editors themselves work with a different space, that is, in linear. Accordingly, the picture must be converted to sRGB to be displayed correctly on the monitor. What happens if you don't convert it? It will be too dark or, on the contrary, overexposed for us, and we'll hardly be able to see any details on it. Now I will explain why you need to do this color conversion. Look at this gradient. It is currently displayed in linear color space. If I ask you to select a medium gray color on it, you will indicate it somewhere here on the left side. This is because the human eye is well trained to distinguish details in the dark. After all, there may be a predator there. But it distinguishes shades of light much worse, and therefore the right side of the gradient seems to us as a solid white stripe. To make the picture richer and more detailed, we need to apply a gamma correction. That is, return the gray color to the middle of the gradient and adjust all other shades to it. Thus, applying gamma correction when working in 3D, you will get better shadows, more detail in the illuminated parts, and in general, you will significantly reduce the time for setting up lighting. I will show you how to set up conversion and output to sRGB in Redshift. You're actually in luck, because with Redshift 3.0.49, we are doing color work in ACCG gamut by default. You can find this group of parameters here. The current workflow is listed here. The default is ACCG. ACCG is a linear color space with an ultra-wide gamut greater than sRGB. It is great for 3D artists. Displays in sRGB mode as another is not possible on my display. Also, tone mapping SDR video is enabled by default. I really like it when this setting is turned on. What is tone mapping? Tone mapping helps you to prevent overexposure. Without tone mapping, you will have bright white areas in which details will be difficult to see or indistinguishable at all. The tone mapping desaturates these highlights. If you don't like using tone mapping, select the Untone Mapped option, but I recommend that you use the default options. If you like to assemble the final image in a compositing program such as Fusion or After Effects, you should set the following settings. Set View to Raw, and uncheck Compensate for View Transform. And one more very important point. Remember, in the previous lesson, we made a wood material and needed to set the correct color space for the roughness texture. Now we will discuss this point again. As we said, the textures that we use in the shader need to be converted. Redshift can recognize the desired color space itself. This is the auto mode, and convert. But sometimes we need to specify it ourselves. So for sRGB, this is PNG or JPG, albedo or diffusion, we specify the sRGB color space. For black and white maps such as bump, roughness, displacement, as well as maps containing data such as normals, raw. For HDR maps and EXR scene linear rec, 709 sRGB. Now let's see how to save your result. When you render an image, you can save it from the File, Save Image as Render window. You can also select the PNG or JPG format in Save and specify the path where to save the picture. If you render a video, you need to either render a PNG sequence and then convert it in Photoshop, or select the MP4 format in Save, and in the output frame range, all frames or the desired frame range, and specify the path. Choose the Render to Picture Viewer option in Render menu. Now we just have to wait. In this window, we see how much time it takes for one frame. Thank you for your attention. I hope this lesson was useful. I wish you creative experiments and fast rendering.